Welcome back. This is our Algebra 2 Sequence and Series Lesson number 2, Arithmetic and Geometric Sequences Home Review Part 4. And please make sure you catch parts 1, 2, and 3. If you have any questions or comments, please make sure you leave them in the comment section below. And if you can, give this video a like. Look forward to getting any feedback from you guys. Make sure, hopefully, I can make these videos better for you. So for number 8, given that A1 is 5 and A2 is 15, are the first two terms of a geometric sequence. It tells you geometric, so determine the values of A3 and A10, show the calculations that led to your answers. In this situation, what we need to do is to find our nth term. Well, we can definitely find A3 just by finding the common ratio and then multiplying by that R value. But to find A10, we probably want to find A sub n, the nth term here. So here we go, and our formula is A of n is equal to A1, our first term. The nth term is equal to the first term times R raised to the power of n minus 1. Okay? And so the R value, well, R value can be found by taking the second term divided by the first term. And since they tell us that A2 is equal to 15 and A1 is 5, we can then substitute and get 15 over 5 is equal to 3. Okay? And so now we want to find, our terms in this case, numerical term. All right, so we say an, nth term, is equal to, our first term is A1's 5. So we have 3 times 3 raised to the n minus 1 power. And that's the form we're going to use. Now, it's not the simplified general form, because at that point we would probably get, some fraction. But for ourselves in this case, we want to find the third term and the 10th term. We can just plug in a equals 3 and a equals 10 and using this, and that'll be totally good. So here A3 is equal to 5 times 3 raised to 3 minus 1. And so we would get A3 is equal to 5 times 3 squared. That's 5 times 9. A3 is equal to 45. That's not so bad. And then we could have just figured out, well, the R value is 3. 15 times 3 is 45. Well, now we want to find A10. So A10, that's equal to, again, 5 times 3 raised to the 10 minus 1. Well, that means A10 is equal to 5 raised to times 3 raised to the 9th power. And that might be kind of a big number. So we'll get our calculator out here. And we're going to, in this case, try to find 3 to the 9th power. Okay? So I'll clear this here. 3 raised to the 9th power. We get a big number here. A10 is equal to 5 times 19,683. So we multiply that number by 5 times 5. We get A10 to get a, again, with the calculator, it's not so bad, 98,415. It is much easier to use this formula to be able to find the nth term. So nth term, again, remember, the first term times R raised to n minus 1. And so that will be how we find our nth term here. Question number 9. In a geometric sequence, it is known that A1 equals -1 and A4 equals 64. The value of A10 is going to be, okay, well, we are going to find our general formula, all right? And a couple of things we do know. A of n, again, is A1, the first term, times R raised to the n minus 1. Now, we definitely have A1. That's totally okay. We do not know what the R value is, but that can be calculated. Because if we know A4, that means when n equals 4, okay, so a of n equals 64 when n equals 4. And so we'll use this A4 equals 64 to help us find our missing R value. So we have 64, replaces A sub n, equals -1 for A1 times R, and the n value is 4, so it's going to be 4 minus 1. Well, we'll simplify this. So we have 64 equals -1 times the R value raised to the third power. Divide both sides by -1. So -64 equals R to the third. Now, normally in this case, we would raise both sides to the 1/3 power to get the base by itself. It's something we learned back when we were doing all those wonderful problems with exponents and exponential functions. So here, what number multiplied by itself 3 times, r times r times r, equals -64? And that would be -4. Because -4 times -4 is 16, times -4 is -64. Now this is helpful for us because now, because we're looking for a 10, we're going to be plugging in here and using the formula again, but this time an we now know is general form -1 times -4 raised to the n minus 1. All right, so that means a10, our 10th term, is going to be -1 times -4 raised to 10 minus 1, or a10 equals -1 times -4 to the 9th power. And so what we want to do, again, take our calculator, and we'll find in this case -4 and raise that to the 9th power. Give us a really big number, a10 equals -1 times -262,144. And when you multiply that by -1, we get positive. So a10 is positive 262,144. And that's our value for a10, what we're looking for. So that's choice 2. So we definitely, in this case, were able to use our information we had from A4 and A1 to figure out R value, come up with a general formula, and then from there, be able to find the nth term. Our last question here. Oops. Our last question here. And so here, the Cottage Snowflake is a mathematical shape known as a fractal that has many fascinating properties. It is created by repeatedly forming equilateral triangles off of the sides of other equilateral triangles. Its first 6 iterations, well, technically, I only show 4 here. So this first 4 iterations, change that to 4, F-O-U-R, are shown to the right, okay? The perimeters of each of the figures form a geometric sequence. So if the perimeter of the first snowflake, which is a triangle, is 3, so that's why I had the 3 there before. I'll have here 3. What is the perimeter of the second snowflake? Note that the dashed lines of the second snowflake are not to be counted towards the perimeter. They're only there to show how the snowflake is structured. So we see in this case that if this here, this smaller piece is an equilateral triangle, right? That means each of these sides of those pieces are the same. And that being the case, each of these sides of this equilateral triangle are going to be, if this whole thing is 1, then this is 1/3. Okay? And so now each of these sides here is 1/3, and we have, in this case, I'll mark them off, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 sides times 1/3. Okay, so 12 times 1/3 equals 12 thirds, or or 4. So the perimeter of the second snowflake is 4. And we'll just type that in there. Okay. The perimeter of the second snowflake is 4. So that's the answer. I'm down here. Okay. That's part A. Again, we talked about how one full length is 1. Therefore, each of these pieces is 1/3 because this piece plus this piece plus this piece form on length of 1. So each of the smaller pieces is 1/3. So we count each of these 1/3 pieces are going to have, we'll have 12 of them to form this snowflake. And so 12 times 1/3 is going to be 4. So now they tell us that the perimeter is going to be a geometric sequence. So given the perimeters form a geometric sequence, what is the perimeter of the 6th snowflake? And express your answer to the nearest 10th. So here's the thing, okay? If this is a geometric sequence, then we know in this case we can use the formula A sub n is equal to A1 times R raised to the n minus 1. Okay? And we know our, well how we find our R value? Well, the first term was 3. So A1 is 3, so we have that. And A2 is 4. Our ratio can be found by taking A2 over A1, and therefore our R value is 4/3. So we can replace this here for the formula AN, oops, that's wrong, AN equals A1 times 4/3 to the n minus 1. Or in this case, A1, which is, so A 6, because we're looking for the 6th snowflake, is equal to A1, which is 3, times 4/3 to the 6 minus 1, or 5th power. Okay? And so now we're going to multiply this. Okay, so take our calculators out, and we're going to multiply. So we see here, we're going to take our starting value, A1, was 3, and we're multiplying by 4/3, 4 over 3, raised to the, in this case, it's 6 minus 1, so 6 minus 1. We can put down 5. And we get 12.64197531. Now we could find this fraction, hitting math, enter twice, as 1024 over 81, but they were satisfied with a rounding off to the nearest 10th. And so we're going to now get, in this case, 12.6. Okay, so approximately 12.6 is our perimeter. And for our last question, it says, if this process allowed to continue forever, explain why the perimeter would become infinitely large. Well, the reason why we infinitely large would be the fact that because we're multiplying by a number greater than 1. So we would say, because our R value is greater than 1, we would get values that would continue to grow without bound. So really it's about the R value in this case. Okay, everybody? All right, ladies and gentlemen, thanks so much for watching on this full page for you guys. Again, if you found this helpful, please give this video a like and subscribe to the channel. And leave any questions or comments in the comment section below. Turn on notifications to be alerted when new videos are added. And look for our next videos. Thanks again. Take care, everybody. Be safe.